Hello students, in previous part we have been seeing the definitions of permutation and combination. Now in this video let us see some more examples on the same permutation and combination. Also we will see later on permutation with repetition and combination with repetition also. So before that let us see few examples. So first example, let it be that how many ways are there to distribute 5 cards to each of 4 players from a standard deck of 52 cards. Standard deck of 52 cards. The solution for this one. Now we have total number of players are 4 and we have to give 5 cards to each of them from the standard deck of 52 cards. So 5 cards of first player can be chosen from 52 cards in C52 5 ways. Again, now remaining cards are how many? 47. So second player get 5 cards from remaining 47 cards. The ways are how many there? C47 5 ways. Okay. And similarly for the other also. We can say the answer, the 5 cards of first player from 52 cards can be chosen from or by C52 5 ways. Once he choose the 5 cards, then the remaining cards are how many? 47. Remaining cards are 47. Therefore, the second player can choose can choose 5 cards from 47 cards in C47 5 ways, and same for others, so and so on. Therefore, total number of ways are how many? Just we will take a product of them. As these are independent events, so multiplication rule is applicable. So first player has C52 5 multiply by second player has C47 5, third player has C47 minus 5, so 42 5, and again C37 5 as such. These are the ways to choose or to distribute 5 cards to each of 4 players from the standard deck of 52 cards. Now the next example, let me write that there are many cases. So now the next example is that a class consists of 5 girls and 7 boys. Okay. So now the first question is that how many ways a committee of 5 students can be formed. Committee of 5 students can be formed. Second, in how many ways can a committee of 3 girls and 2 boys be formed? Then the next, in how many ways can a committee of 5 students having at least 3 girls be formed? So now solution for this one, let us see. The first one, now total 5 girls and 7 boys are there in class. So total students are how many? 12. So now in how many ways the committee of 5 students? So total students are 5. Total students are 12. There is no condition to choose these 5 students out of these 12 students. So for the first one, the committee of 5 students we have to form from these 12 students. So we have to select 5 students from these 12 students. So this can be done by 5 ways. So the answer of first one is very easy. In all there are 12 students in a class. Therefore 5 students can be selected. 5 students can be selected in (12C5) ways, that is 792 ways. Now the second one, in how many ways the committee of 3 girls, means out of these 5 girls we have to select 3 girls, and 2 boys, means out of these 7 boys we have to select 2 boys are there. So now selection of girls and the selection of boys are independent events. So we will found first the ways of selection of girls and the ways of selection of boys, and we will take the product of them, as it is these are independent events. So simply I will write 3 girls can be selected. 3 girls can be selected from 5 girls in 5C3 ways, and 2 boys can be selected from 7 boys in 7C2 ways. Therefore total number of ways are how many here? As we say, the product of these one, that is 5C3 multiplied by 7C2. The value of 5C3 is 10 and 7C2 is how much? 21. So total 210 ways are there. Okay. Now the third question, in how many ways can a committee of 5 students having at least 3 girls? So at least means what? Minimum. So minimum 3 girls. So maximum more than that means maximum, at most are how many? 5 are total there. So at most 5 girls are there. So there are different cases will come here. Now let me write the cases and I will explain side by side to you. Case, let me say boys. How many boys with us? 7 boys. And girls, how many girls with us? We have 5 girls with us. Okay. And let me write here number of ways. Number of ways. So here suppose case 1. Now when 3 girls we have to select, the condition for girls. So at least 3 girls, that time the committee of 5 members, 5 students we have to form. So if we have been selected 3 girls, then 2 boys we have to select. Fine. The same as we have in the second question. So number of ways are how many here? 7C2, 7. From 7 we have to select 2. So 7C2 multiply by what? This 5C3. Out of 5 we have to select 3. So 5C3. Now suppose the girls, the selection of girls is suppose 4. We have been selected 4 girls. That time to form the 5 student committee we have to select only 1 boy that time. Fine. So the number of ways are how many? 7C1 multiply by what? 5C4. 5C4. The third case, now it may possible that we can select 5 girls because the condition is for minimum 3 girls, not for maximum are how many. So maximum 5 girls if we have selected, then the committee has only girls are there. So boys are how many? 0 there. So this can be done by 7C0 multiply by what? 5C, 5 ways. So now these are different cases. So mutually exclusive cases are these. So if such a things are there, then already we have seen we need to add these things that are the total number of ways of such a selection. So lastly I must write that hence the total number of ways for or total number of ways to form a committee of 5 students have or having at least 3 girls. At least 3 girls. That is equal to addition of these 3. So 7C2 multiply by 5C3 plus 7C1 multiply by 5C4 plus 7C0 multiply by 5C5. Now 7C2 is how much? 21. 5C3 is 10 plus 7C1 is 7. Okay. 7C1 is 7 factorial upon 6 factorial. So it will be 7. And this is 5C4 is how much? 5. So this is 5 plus 7C0 is 1 and 5C5 is also 1. This is 1 multiplied by 1. So this is 210 plus 35 plus 1. So 210 plus 35 will be 245 plus 1 will be 246. So total number of ways are how many? 246 are here. Okay. Now let me take the next example. How many bit string, how many bit strings of length 8 contain exactly 3 ones. Exactly 3 ones. How many bit string of length 8 can contain exactly 3 ones? So means we have to choose 3 places for ones and remaining places are with 0. Fine. So this can be done by 8C3 ways. This is simple question, 2 mark question. It is a very small question. So the 3 places for ones can be chosen in 8C3 ways and the remaining places will be filled by 0 only. Therefore, the total number of ways are how many here? Total number of ways are just 8C3. Fine. This is the answer here. Now, the next part we have to see permutation with repetition. Now, counting permutation with repetition of elements is allowed and it can be done easily using the product rule. Now, that time the repetition is allowed means what? Suppose we have 3 numbers 1, 2, 3. So, each place have these 3 choices to arrange them. So, 3 multiplied by 3 multiplied by 3. So, this is just, this place will be filled independently than this one. So, here we are using the multiplication rule clearly. Fine. So, there is a small theorem. Before that, let us write down the heading: permutation with repetition. Permutation with repetition. Whatever I say, just the same thing is given in that theorem. It is just a statement. Now we have to use that theorem while solving the example. So means what the theorem says? The theorem: the number of R permutations, of a set of n objects, with repetition is, this can be done by n raised to r ways. So now, as an example, how many ternary sequences of length 10 are there? The question is that, suppose how many ternary sequences of length 10 are there? Okay. Now, you know, in ternary sequences the digits are allowed. Which digits are allowed? 0, 1 and 2 only. So for each place we have 3 choices and we have to form such a sequences of length 10. So each place have 3 choices. So each place will be filled by, there are total 10 places. Such a thing. These 10 places are supposed, and each place have how many? 3 choices. So the product rule is applicable in them. So these are nothing but 3 raised to 10 number of ways to select such a sequences. Fine. Or to form such a sequences. So in a ternary sequences, or the sequence, the digits are allowed, the digits are allowed, digits allowed are, suppose digits allowed are 0, 1 and 2 only. Okay, so therefore for each place we have 3 choices. We have 3 choices. Therefore, number of ways to form such a sequences of length 10 are what? 3 raised to 10. These many number of ways are there. Now let me take one more example for this. A very simple thing is this. So there are not more examples on this. Simply if we take 2 or 3, this is enough for that. Now how many ways are there to assign? How many ways are there to assign 3 jobs to 5 employees? 5 employees, if each employee can be given more than one job. Each employee can be given more than one job means the repetition is allowed. So now we have to assign 3 jobs and total employees are 5. So for these 3 places we have to fill and we have 5 choices. For each one we have 5 choices, as each employee can given more than one job, so repetition is allowed. So this says here, for assigning each job we have 5 choices, therefore total number of ways are 5 into 5 into 5, that are 5 cube, that is 125. A simple thing here, for assigning each job we have 5 choices, therefore total number of ways to assign 3 jobs are how many? 5 into 5 into 5, that is 125. Okay, so this is about what? The permutation with repetition. Here we will stop for today. Next video we will see the combination with repetition and also the permutation with indistinguishable objects. Thank you.